If you knew gummy candy was made from animal bones and skin, would you still want to eat it? It might sound strange, but it's true. According to the Gelatin Manufacturers Institute of America, in 2021 alone, Americans consumed around 60,000 tons of gelatin, mostly from gummy candy, marshmallows, and pudding. And most of that gelatin doesn't come from where you think. Gummy candy isn't an American invention. It originated in Germany in the 1920s, when a candy maker named Hans Riegel created what we now know as the HARIBO gummy bear. From a small workshop in Bonn, he turned gummy candy into a global phenomenon.
Goldbeeren von HARIBO.
HARIBO macht Kinder froh
Und Erwachsene ebenso.
By the 1980s, gummy candy officially entered the US market, and since then, it's become a staple on every snack aisle shelf. At the factory, the process starts by mixing the key ingredients: sugar, corn syrup, water, flavorings, food coloring, and of course, gelatin. Gelatin is the main texturizing agent. It gives gummy candy its signature chewiness and elasticity. And just like you heard at the start of this video, it's not a plant-based ingredient like many people think. Most commercial gelatin is extracted from pig skin, cow bones, and sometimes fish, parts left over from the slaughtering process. For some, it's a smart way to reduce waste. For others, the idea of eating a sweet treat made from animal bones and skin is still hard to swallow. Some argue that gelatin should be more clearly labeled for health, religious, or simply right-to-know reasons. Equally controversial is the food coloring, the stuff that gives each candy its bright, eye-catching look. In the US, colors like Red 40, Yellow 5, and Blue 1 are approved by the FDA for use in food, including gummy candy. However, in Europe, some of these substances are more tightly regulated or even require warning labels, especially when marketed to children. The food industry says it's all within safe limits, but some studies and consumer groups want a closer look at the long-term effects. So, what do you think? If the candy still tastes the same, but looks a little less colorful, would it matter to you? Once the gummy mixture is fully blended and reaches the right hot, syrupy consistency, it moves to the molding stage. Every gummy candy starts with a mold, but surprisingly, they don't use plastic or metal molds like many assume. Instead, most factories still use starch molds. It may sound old-fashioned, but it's actually an extremely efficient method used in industrial production. Cornstarch is packed into thick trays, then a stamping machine prints the desired shape, from bears and fruits to worms, creating rows of precise, hollow impressions. The hot gummy mixture is automatically poured into each mold. This entire step is fast, with high precision in temperature, volume, and pouring speed. Why use starch molds? There are three main reasons starch molds are still preferred, even with modern plastic mold technology. First, cornstarch can withstand high heat and doesn't warp when exposed to the 70 to 90 degrees Celsius mixture. Second, starch absorbs some of the moisture from the mixture, helping the candy set faster and hold its chewy texture. Third, after each batch, the starch is sifted and reused, cutting costs and saving time while still meeting hygiene standards. So while it may seem outdated, starch molds remain a simple, effective solution, shaping millions of gummy candies every day. After molding, the gummies are removed and sent through a cooling tunnel. Here the temperature is kept around 18 to 24 degrees Celsius to let the candy cool gradually, avoiding heat shock that can cause warping, cracking, or uneven texture. Once cooled, the gummy is fully formed in shape and texture, but if you look closely, it's still dull and sticks easily to others. To fix this, manufacturers apply an ultra-thin coating of edible wax, usually beeswax, carnauba wax, or vegetable oil. Among these, carnauba, extracted from Brazilian palm leaves, is the most common. It's colorless, odorless, edible, and FDA approved for food use. It only takes about 0.1% of the candy's weight, but this layer makes the surface smooth, dry, non-sticky, and most importantly, keeps gummies from clumping during packaging. For certain products, especially sour gummies or tropical fruit gummies, the coating is a layer of crystallized sugar or a sugar acid mix instead of wax. This sugar coating not only adds flavor, but creates a light crunch when you bite into the gummy surface. Now the gummies are ready for the final step, packaging. They're funneled through weighing machines, accurately dividing them into 100 gram, 150 gram, or 250 gram bags, depending on market requirements. Then comes the heat sealing, batch coating, expiry date printing, and boxing. A modern packaging line can handle 150 to 200 bags per minute, translating to millions of gummies packed every week, sent to supermarkets, convenience stores, and retail outlets across the US. Marshmallows still use gelatin, but what gives them their signature texture isn't what you'd expect. Marshmallows still use gelatin, but what gives them their signature texture isn't what you'd expect. It's not the sugar, it's not the gelatin. It's something no one really thinks of as food. In fact, marshmallows can be made of up to 60% air, which means, basically, you're eating air. Wait, what? The name marshmallow comes from the marshmallow plant, a plant that grows in marshes, which was once used as a folk medicine in ancient Egypt. The plant's root contains a natural mucilage, which was extracted and beaten with honey to create the first version of marshmallow. By the 19th century, the production method changed entirely. The plant's root was replaced with gelatin, cheaper, easier to store, and provided a more stable texture. From there, marshmallow gradually became a popular sweet, associated with campfires, s'mores, and even American snack culture. If you found this content helpful, don't forget to subscribe to the channel to follow our next videos. The process begins with soaking gelatin in water. The gelatin is placed into the stand mixer and soaked for about 15 minutes to absorb water and fully expand. This is an important step for the gelatin to activate its binding properties and form the structure of the marshmallow. During this time, workers prepare a mixture of sugar, corn syrup, and a small amount of water. Sugar provides the main sweetness, while corn syrup helps control crystallization, keeping the mixture soft, elastic, and preventing it from drying out as it cools. The mixture is heated to 240 degrees Fahrenheit, about 115 degrees Celsius, which corresponds to the soft ball stage, a key temperature point in candy making. Once the syrup mixture reaches the proper temperature, the worker turns on the stand mixer at low speed and slowly pours the hot syrup into the expanded gelatin. Pouring slowly and continuously helps avoid thermal shock and ensures the mixture blends smoothly. After all the syrup is added, the mixer speed is gradually increased. This process incorporates air into the mixture, creating millions of tiny air bubbles. These bubbles give the marshmallow its light, soft, and fluffy texture. At this stage, the gelatin acts like a supporting net, holding the air bubbles in place. Thanks to this, the marshmallow retains its volume and doesn't collapse after whipping. When the mixture turns opaque white and begins to thicken, vanilla is added for aroma. The whipping speed is then raised to a high level, 2,000 to 3,500 RPM, making the mixture smooth, uniform, and light. The result? The mixture doubles in volume, with about 50 to 60% of it consisting of air bubbles. Immediately after whipping, while the mixture is still warm and pliable, workers proceed to the shaping stage. Before this, the trays are carefully prepared, sprayed with a layer of food-grade oil to prevent sticking, then dusted with a layer of fine powdered sugar, a blend of icing sugar and cornstarch, to help the marshmallows from sticking to the bottom and sides of the tray. The marshmallow mixture is poured into the tray from the edge in a steady, even flow to avoid forming large air pockets or empty spots. Workers use a spatula or straight edge to gently spread the mixture, starting from the corners and moving toward the center. The spreading technique requires a light but steady hand to evenly distribute the mixture without deflating the air bubbles. The thickness of the marshmallow layer is usually controlled between 2 to 3 centimeters, depending on the product type. After spreading, workers check the surface and smooth out any raised areas to ensure the marshmallow sets evenly and looks clean after cooling. The thickness of the marshmallow layer is usually controlled between 2 to 3 centimeters, depending on the product type. After spreading, workers check the surface and smooth out any raised areas to ensure the marshmallow sets evenly and looks clean after cooling. Once the marshmallow has cooled and set, it is removed from the tray, placed on a cutting board dusted with powdered sugar, and then cut. The knife is sprayed with oil to prevent sticking. The marshmallow is first cut into long strips, then further divided into square pieces of uniform size. In addition, some of the marshmallow may be piped using a pastry bag to create twisted, multicolored marshmallow ropes, forming products with visually appealing shapes. After cutting, each marshmallow piece is coated with an additional layer of fine powdered sugar to prevent sticking during storage and packaging. This coating also helps keep the surface dry and extends freshness. The finished product has a soft, elastic, and evenly airy texture. When dropped into a cup of hot chocolate, the marshmallow slowly melts and blends into the drink, creating a sweet and cozy sensation. Did you know that more than half of the marshmallow you're eating is air? Does that change the way you see this candy? From a soft foam mass to a candy with a hard shell and a chewy inside, this process is a completely different story. In the US, many people refer to jelly beans as fruit candy. But there's no fruit in them, no juice, no fiber, no vitamins. All the flavor, color, and sweetness are in the outer coating. The inside hardly has any taste. What you're eating is not a candy with a shell, but a shell designed to look like candy. Jelly beans originated in the US, appearing in the late 19th century. The first person credited with popularizing this candy was William Shraft, a candy shop owner in Boston. In 1861, during the Civil War, Shraft encouraged people to send jelly beans to soldiers as a comforting gift. The structure of jelly beans is believed to be inspired by Turkish delight, a traditional chewy candy from the Middle East, and the sugar coating technique used in tablet production. By the early 20th century, jelly beans gradually became a popular treat during holidays, especially Easter, thanks to their bright colors and egg-like shape. The filling, the candy core, is made from a mixture of sugar, corn syrup, water, gelatin, starch, and flavorings. Sugar and corn syrup make up the majority, about 50 to 60% of the mixture, providing the candy's sweetness and keeping it moist after completion. Gelatin and starch are the structural ingredients. Gelatin gives elasticity, and starch helps prevent the core from being too runny. Everything is cooked in a vacuum pot at a temperature of 130 to 140 degrees Celsius for 15 to 20 minutes. Once the mixture reaches the right consistency, it's transferred to a filling machine, where it is divided into small drops and poured into molds made from compressed cornstarch, similar to gummy candy molds. These cornstarch molds have thousands of small oval cavities, shaping each jelly bean. After pouring, the fillings are left to cool naturally for 24 to 48 hours. During this time, the gelatin and starch set, creating a firm but chewy core. The cornstarch also absorbs excess moisture, helping the surface of the core dry out and avoid sticking. After the centers are removed from the molds, they go through a rotating drum that applies the first layer of sugar. This layer is thin, colorless, and serves as an anti-stick barrier, preventing the centers from sticking to each other during the next processing steps. Next, the candies are placed into a panning drum, a stainless steel vessel that rotates continuously at a moderate speed. One by one, layers of syrup mixed with coloring and flavoring are added. Each layer must dry completely before the next one is poured on. This process is repeated 20 to 30 times to form a thick, even, crunchy shell without cracks. The total time may range from 4 to 6 days, depending on the recipe of each candy type. Throughout the coating process, room temperature must be kept stable at 20 to 25 degrees Celsius, with humidity below 40%. Otherwise, the sugar will absorb moisture and melt, resulting in a surface that does not meet quality standards. Once the shells reach the desired thickness, the candies are transferred to a polishing drum, where beeswax is sprayed while the candies rotate slowly. This wax accounts for only about 0.1% of the candy's weight, but it creates a porcelain-like shine, prevents sticking, and helps preserve color during storage. More than half of the time spent making jelly beans is devoted to the shell. The question is it still a coating, or is it the candy itself? After polishing, the jelly beans are complete in appearance, but they still lack their fingerprint. In this final step, the candies pass through a printing system, either thermal or laser printing. The jelly bean logo or a custom image is printed directly onto each piece with near-perfect precision. This step does not alter the flavor or structure, but it is what defines the product. Finally, jelly beans are sorted by color, by flavor, or randomly mixed. A dispensing machine portions them out and packages them into 100 gram, 250 gram, or 400 gram bags, depending on the market. The packaging speed can reach up to 100,000 beans per hour. The finished product is labeled with batch codes, expiry dates, and sent out for distribution, mostly for holidays like Easter, Halloween, or Christmas. Which flavor do you like the most? Or is there a brand you always choose? Leave a comment below. And now it's time for another type of candy, one that doesn't start with gelatin or syrup, but starts with real fruit. What we're calling fruit. Fruit has all of its water removed, boiled multiple times, soaked in sugar continuously for nearly 10 days, and then dried at 60 degrees Celsius until all that's left is the sweetness. No more vitamins, no more fiber, just the shape and the sweet taste. And it's still called fruit. So, in your opinion, can candied fruit still be considered fruit? Candied fruit is not a modern invention. On the contrary, it is one of the oldest food preservation techniques ever recorded. Since the 9th century, Arabs have used honey and concentrated sugar to keep fruits from spoiling, both sweet and durable. This technique spread to Europe during the medieval trade. In France, Italy, and especially in the Mediterranean region, candied fruit became a luxury gift, only appearing at aristocratic banquets. By the 17th century, the town of Apt in southern France was regarded as the capital of candied fruit. Many candy makers still exist here today, but most modern candied fruit production has shifted to an industrial scale, with nearly perfect control over temperature, humidity, and sweetness. Common raw materials include fruits with firm structures and slightly sour tastes: oranges, lemons, pineapples, kiwis, grapefruit peel, orange peel, ginger, lemon peel, or cherries. Some factories even use green papayas, watermelon rind, or unripe mangoes, depending on the market and season. The fruits are harvested from the fields and carefully transported by truck to the factory, where they will undergo sorting and processing. The fruits are carefully sorted, separated by size, ripeness, and quality, ready for the next stages of processing. With a large quantity of fruits harvested daily, the factory is capable of handling tons of products, ensuring a steady supply of raw materials for the production line. After sorting, the fruits are placed in water tanks for washing. Each tank can hold up to 1 ton of fruit, with water pressure adjusted to as high as 150 psi. The machine uses high-pressure water jets to clean dust, dirt, and natural oils off the peel, removing up to 95% of impurities, ensuring the fruits are clean and safe. After washing, the fruits are sent through a sorting conveyor. Larger fruits are cut into smaller pieces of appropriate size for easier processing. For other fruits, such as pineapples or mangoes, the system will peel, remove seeds, and cut them into smaller portions, with a thickness of 5 to 8 millimeters. The pieces must be uniform, not too thin to avoid crushing, and not too thick to ensure they soak evenly during the next processing stage. Orange or grapefruit peels will be treated further, placed in a steam boiler, briefly boiled at 95 degrees Celsius for a few minutes to reduce bitterness. Then they are cooled with a fan and drained to prepare for the next boiling step. Next is the heat treatment step, called soft boiling. The temperature is kept steady at 90 to 93 degrees Celsius, with boiling time ranging from 7 to 12 minutes, depending on the type of fruit. The goal is to soften the cells just enough for the sugar to penetrate, but not break the tissue structure. If overboiled, the fruit loses its shape. If underboiled, the sugar won't soak deep enough. This is the core stage. It takes several days and requires almost perfect stability. The fruit slices are placed into a soaking tank with slow stirring blades and a syrup circulation system. The tank is heated from the bottom to maintain the syrup at 80 to 85 degrees Celsius without boiling. Initially, the syrup has a concentration of about 30% bricks. The fruit is gently cooked in it for about 30 to 45 minutes, then left to cool slowly. Afterward, it is soaked for another 12 to 24 hours. The next day, the old syrup is drained out and sent to a filtration system for reuse. The syrup is replaced with a new, more concentrated batch, 40% bricks. Then 50%, 60%, and up to 70 to 75% by the final days. The entire soaking process may take 5 to 10 days. The sugar gradually penetrates the fruit slices through reverse osmosis, replacing the water inside the cells. This slow soaking process ensures the fruit keeps its shape, color, and texture, and prevents sugar crystallization on the surface. Once the desired sweetness is achieved, the fruit is removed from the syrup, drained on a stainless steel mesh tray, and then placed into a drying chamber. Each chamber has a fan that circulates hot air evenly from the bottom up. The temperature is maintained at 50 to 60 degrees Celsius for 8 to 12 hours. Throughout the process, temperature and humidity sensors continuously monitor the fruit to ensure it doesn't dry out too much at the edges or retain moisture in the center. The final moisture content must be below 15%, enough to keep the fruit chewy but not sticky and suitable for long-term storage. After drying, the fruit is moved to a horizontal mixing machine, where a thin layer of powdered sugar or dry glucose is applied through a dowsing funnel. This layer prevents the product from sticking and keeps the surface dry. Afterward, the product is packaged and the production date along with the batch code is printed. The finished bags are checked again, packed into cartons and stored in a low humidity warehouse to ensure quality during storage. Though starting from fresh fruit, after nearly 10 days of processing, from multi-stage sugar soaking, heating, and drying, most of the natural nutrients are almost gone. The final product loses the sour taste, moisture, and nutritional value of the original fruit. But in terms of origin, structure, and the way it retains its shape, many still consider this a form of fruit preservation using a traditional technique. So, is candy fruit still considered fruit? Perhaps. It depends on how you define fruit. 4 types of candy, 4 very different methods, but they all have one thing in common. What you eat is not as simple as it looks. From gummy candy with its distinctive chewy texture thanks to gelatin, marshmallows as light as clouds with over 50% air, jelly beans crispy and shiny with their colorful shell, to candied fruit, chewy, sweet, and fragrant, like a way to preserve fruit with sugar. So, after all, which one do you choose? Gummy, marshmallow, jelly bean, or candied fruit? Leave a comment and let me know. And if you want to continue exploring other fascinating food processes, don't forget to subscribe to Captain Discovery. See you in the next video.